Hello and welcome. On behalf of Beyerdynamic, I would like to welcome you to our first NAMM expert talk, Pro X, the evolution of sound. My name is Philipp and by my side is Sebastian,
Hi.
our acoustic engineer. And now we want to run you through several topics. First of all, we will discuss new Pro X microphones and give you some insights, some details about the development process, the product itself, and the technical specifications. Afterwards, Sebastian will tell you something about the Pro X headphones and the development. And afterwards, we will have a Q&A session where you can ask your personal questions. And of course, we'll try our best to answer them. So, just a little bit about the company itself. Beyerdynamic was founded in 1924 in Berlin, Germany, and now we're in Heilbronn, Germany, located. And after all this time, we accumulated a lot of experience, and of course, innovation and sound optimization are really staples of Beyerdynamic. So we actually started out with one of the first dynamic headphones for music listening purposes and audiophile purposes, which was the DT48, released in 1937. And from this point on, we of course developed, based on this product, a lot of different headphones, and all the acoustic expertise went into our new products, and of course our more current products such as the DT770 or the DT990, which you may know as mixing or mastering headphones for music recording, and of course they also found their way into the gaming setups or the audiophile setups today. But Beyerdynamic is also known for microphones. And did you know that we actually released one of the first dynamic microphones actually suited for music and voice recording, which was the M90. And legend has it, it was tested, or it was developed for radio studios, and it was actually tested for its durability by throwing this one out of the second story of a radio studio. And of course, it survived its fall. Based on this dynamic principle, we developed a lot of different microphones that are icons in the studio world and in the broadcast world right now. For example, the M88, which is loved by many as a kick drum microphone, as a guitar microphone, or even a singing microphone. Following that, we also developed products such as the M160 double ribbon microphone, which is until now one of our most beloved products, and a product that's just loved by fans and the whole community. Also very well suited for guitar recording or even drum recording, such as a drum overhead microphone. So why this little company excursion? We want to show you in these next 30 to 40 minutes what the company is like, what our development process is like, what the experience is that we gathered over the time, and how it influenced our products today, and especially our Pro X products, which are aimed at the modern creator target group and also incorporate a lot of these values. So I think now we can start with the microphones. Addressing the current trends of streaming, podcasting, broadcasting at home, we wanted to create a microphone that gives the user a really radio-like and really polished sound from the beginning. And we all know that users today don't have the perfect room setups. So acoustic treatment is not really common. So we wanted to make this a dynamic microphone which rejects a lot of the reverberation or background noises. And this M70 is perfectly suited to record the voice and also rejects those certain noises. We actually looked back during the development to products such as the M201, or a product that you might not know, the M101, which were also dynamic microphones and actually developed for interview purposes. And in these products, you can clearly see that the speech intelligibility and the clarity is one of the main factors when it comes to the sound pickup. So this is what we also wanted to replicate in this product, and we tuned the frequency response accordingly. We also tried to accommodate some of the problems that come with the M201 or the M101, which is sensitivity to plosive noises or sensitivity to shock noises. And this is of course why we have the external shock mount on this microphone, but also an internal shock mount. And it's of course why we have a triple layer pop filter inside of the microphone. And some of the challenges we also have is that not every speaker is really trained, myself including, and moves the head while speaking into the microphone. And this, of course, doesn't always replicate the best sound. So this is also respected in the frequency response to always bring in the clarity and the speech intelligibility that you need to actually hear and understand the person speaking. So these problems were basically all addressed in the microphone, and we went even a step further. Often overlooked is the polar pattern in the microphone. And with the M70, we tuned the polar pattern to be omnidirectional only in the bass frequencies. This has the effect that the proximity effect, which occurs when you move closely to the microphone, is tamed a little bit. So the bass frequency response doesn't rise up as dramatically as with a normal cardioid microphone. This leaves the voice always balanced and retains the high frequencies which you need for speech intelligibility. Mm. So contrary to the design of the M70, we also wanted to make a microphone that is just your universal purpose microphone in your studio. Therefore, we created the M90, which is a condenser microphone, actually a true condenser microphone, which is supposed to be used at kind of every source. So with this microphone, you can record voiceovers, every kind of musical instrument, even drums, even a kick drum. And this versatility was a real challenge, but it was also a challenge to step into the footsteps of other popular microphones from the past, such as the MC840 or the MC740. With these microphones, we had a lot of success at sound engineers or at recording studios, because those engineers loved also the clarity and the openness of the microphone. This is what we also wanted to capture in the frequency response of the microphone. So we kept the frequency response quite open and basically as flat as possible. But we also wanted to give it kind of a modern edge. So you could use this microphone on your vocal recordings, on your instrument recordings without tuning too much in post-processing. And this is why we kind of boosted the highs a little bit just to give it a modern taste. One thing we also wanted to address is the self-noise of the microphone, which is always a problem if you record very quiet sound sources or if you record a speaker that has a very low voice or a very quiet voice. Because if the sound source is very quiet, the self-noise of your microphone becomes audible. And with this microphone, we were able to reconfigure the self-noise level to a bare minimum. So you won't hear the self-noise of the microphone in any certain situation where you record a voiceover, for example, and this saves time and a lot of effort in post-processing. This was actually done by tuning every part of the PCBA and of the low impedance part of the PCBA and the whole amplifier stage, and equip the microphone with modern components to reach this incredible value. What's also really special and what's often overlooked is the polar pattern, because we wanted to keep the polar pattern and the noise rejection from the back as low as possible in every frequency. The result is that the microphone is very phase phase coherence. So you can record sounds even in rooms with a lot of reverberation without the microphone being phasey sounding. And I think this is also really important in spaces where you have a wall without acoustic treatment, just to accommodate this room reverberation and early reflections. So I think these two products incorporate a lot of our strength, a lot of the experience we gathered over the years, and to make sure everything is incorporated, we ran several tests with both microphones. We tested both models on basically any sound source there is, either instrument recordings, vocal recordings, speech recordings, and even tested it with actual users, with pro users, and with everything, with everyone we basically know in our circle of friends. And I think this really helped us to get the best out of it, because in every round and with every feedback we gathered, we had iteration loops where we fine-tuned every detail, and yeah, the result are two great products that replicate the sound exactly how we wanted it and how most of our users wanted it. And without further ado, my colleague Sebastian will take over now and will tell you something about our headphones and about the driver development, especially.
Thank you, Philipp. I will take over now. My name is Sebastian Haberzettl. I work as an acoustic engineer at Beyerdynamic, and today I want to give you some technical details, insights on the Pro X headphone series. You may know that our DT Classics have always stood for accurate and pure sound, and also they are characterized by their great wearing comfort. That's the reason why you will find the Classics in music studios of producers all around the world. Our Classics are well known for their very rich treble, their unadulterated mid-range and smooth mid-range, and their accurate and powerful reproduction of low frequencies. Besides that, they do sound surprisingly spacious and open, even the closed back models, which is quite unique. All these attributes had been very important for us when creating the new Pro X headphone series. And I want to show you both models. We have here the open back version. It's the DT900. You can recognize this by the openings at the ear cup. And you will also see here the closed back version. It's the DT700. And generally what we did is we wanted to keep the sound signature of the Classics, but kind of evolve it a little bit, bring it to the next level. So speaking sound-wise, we varied the treble range in such a way that it sounds a little bit more pleasing, also for longer listening sessions. At the lower end, we improved the bass extension. So especially for the DT900, the open back model, we achieved a quite remarkable low-end extension that you will seldomly find at competitors, which is quite nice. Also we adjusted a little bit the mid-range. So especially for voices and vocals, we gave them a little more presence, and at the same time we adjusted a little bit the stereo width of the soundstage in order to make it more natural, more realistic. And what we did also was to bring the stage a little bit more in the foreground, and this also helped to improve the tonal depth of the representation. So okay, let's go a little bit deeper into the technical features of the Pro X headphone series that also feature the new Stellar 45 driver. So the development of the Pro X headphone was quite a challenging task, I can tell you. We put a lot of effort in it, because the benchmark for us was set already very high with our classics. So we put so many effort in it, and we had to challenge ourselves to create a worthy successor. And the idea was to keep the good things from the classics and implement improvements at those places where it was possible. So for the development, we also considered the feedback of our customers that we gathered the last years or the last decades, so to say. And we finally ended up with a feature list. So please have a look at the features. We wanted to make the Pro X headphones to have a very balanced sound. And also, coming from the DT Classics, we wanted a headphone with improved sensitivity. So this automatically leads to a very high connectivity, so you can use them on stationary devices, on portable devices, on the go. We wanted to keep the distortions as little as possible. And besides that, we also wanted to maintain the good transient response properties from our classics. And also very important for us was the high comfort that you already know from our classics, because the best sound is no use if the headphone gets uncomfortable after long listening sessions. And last but not least, we wanted to maintain a very good quality of the driver unit and also the headphone itself, to ensure that every headphone do sound the same. And this also holds for the driver, of course. We already talked about sound, but as I said, we also wanted to create a headphone that is very versatile in its field of application. For example, when it comes to weak audio devices where the output volume is limited. And also here, the Pro X headphone shall deliver a very high sound pressure level. So technically, it needs the headphone needs a very high sensitivity, or in particular, a very high voltage sensitivity. And from that perspective, one can say that we kind of the Pro X is a kind of evolution from the DT Classics, because the headphone can now handle low output audio devices. So this is quite nice. And finally, we ended up with a very high sensitivity of 100 dB per milliwatt. So this is similar to our Pro Tesla headphones, like the DT1770 or the DT1990. So we achieved that by creating a new driver called Stellar 45, and I will give you details on this later on. So generally, when you have a Pro headphone, normally, or the ideal Pro headphone would represent the audio scene, or reproduce the audio scene as intended by the sound engineer, so without any coloration. But when we go into the physics, this means the radiated sound wave, or the sound field inside the ear cup and inside the ear cushion, shall be free from acoustical resonances and cancellation effects. And for the headphone these effects would also lead into the dips or sharp peaks in the headphone's frequency response. So with the driver, the driver already fulfills these requirements flawlessly. But when it comes to headphone acoustics, we needed to add another key element. So with the new Pro X headphone series, we introduced a new type of acoustic pad, as you can see here. This pad has a damping element in the center, and it's mounted or clamped between the acoustic baffle, which holds the driver unit, and the ear cushion itself. And the purpose of this damping element is to prevent sharp peaks that you get due to these resonances that may occur. And one big benefit of this is that you get a smooth treble range, and so also for longer listening sessions you will not get ear fatigue, and you smooth the treble without loss of any detail, which is a very nice feature here. Yeah, I want to speak a little bit more about headphone acoustics. So please have a look at the schematic cross-sectional view. No, I want to show you before the baffle of the acoustic baffle of the driver. Yeah, because there's something special on beyerdynamic headphones, and this is the driver design, and especially the design of the acoustic baffle. You can see here we have an acoustic baffle, and the driver unit is placed in the center of the acoustic baffle, and you see at the circumference there are a lot of openings here, and these openings are covered by an acoustic fleece, which provides a very constant airflow resistance over a broad frequency range. And now let's go to the cross-sectional view to explain you a little bit how it works. You see the acoustic baffle that separates the front and the back chamber of the headphone itself, or the ear cup. And you can see that during operation, the compressed air in the front and back chamber has the ability to stream back and forth through the openings of the acoustic baffle. So this is very important for the overall perceptual sound field, because with such a design you will not feel so encapsulated, isolated from your environment, because the air, the headphone can breathe, so to say. And yeah, this is very important for our very open sound character, even for the closed headphones, this baffle design. And you will seldomly find this one at our competitors. Yeah, going to the next topic, I want to talk a little bit about the wearing comfort, which is very important for a Pro headphone. And yeah, we wanted to, for the Pro X, we wanted to at least keep the very good wearing comfort, or even improve it. And to cope with it, so with a new design, we also introduced a new ear cushion design, which I want to show you right now. You see the ear cushion of the Pro X headphone, and in comparison to our classic ear cushion, you see on top there is a very rectangular shaped design, which improves the sealing a lot. And on the back side, you see we provided like a big radius here, and we provided an undercut. So we gave the ear pinner more room. Yeah. So if you have the ear cushion here, then the ear pinner have enough space, room to get into. So even bigger ears can easily slip into the cushion. This really improved the comfort. So this was very important. And another interesting thing about ear cushions is that they are not only for comfort reasons, so, because they only have an impact on the overall sound character of the headphone. So for example, if you imagine a DT990 and you would attach a closed ear cushion to it, you would get a very strong emphasis in the bass range and at the lower mid range. So please don't do that. This wouldn't sound so good. But this example shows the impact of the ear cushion on the sound. So for the Pro X, we tried a lot of variations, different foam shapes, fillings, ear cushion fillings. We did a lot of fitting tests. And finally, we ended up with a very nice ear cushion design, which also includes a very important soft memory foam that we are using the first time at the Pro X headphone. As you can see, if I compress the foam filling, the release of the compression is quite slowly. So we call this effect creep. It's a mechanical effect, and this is needed because the big benefit of this is that the foam filling stays compressed. So there's no restoring forces from the foam that is pinching your head or your ear. And also the memory foam nicely adapts to the three-dimensional shape of your head. And for the open back version, the DT900, we developed a special kind of foam filling, as you can see here, it's a 2-layer filling. We have the memory foam at the top of the ear cushion, so nearby the head. And at the bottom there is this gray foam, and this is for acoustical reasons. So we have here the comfort and the acoustical foam, so to say. So the gray one acts as an acoustic resistance, which is necessary for the open sound character of the DT900. And let's go back to the cross-sectional view so I can explain you a little bit the interaction of the ear cushion with the overall acoustics of the headphone. And you can see here for the closed-back headphone, no compressed air can go through the ear cushion itself, so you just have the amount of air that is streaming back and forth through the openings of the acoustic baffle. And for the open ear cushion, you see that there is a second acoustic path where the air can get out through the acoustic resistance. So this is very important for the design of the open headphones. So we needed this. Yeah, in terms of comfort, we are quite happy about the new cushion design. We already got replies from some of our customers that they do like the new design even more than the old one, which is quite nice. Yeah, so now let's get to the heart of the headphone, the new Stellar 45 driver. As I already mentioned, the new Pro X headphone addresses a new target group of modern creators that do not always have the possibility to operate in studio-like environments, so they do not have access all the time to strong output devices like headphone amps or stationary interfaces. So this was our motivation. We wanted to create a headphone that do always sound best, whether it is used as a stationary device in the studio or on the go, or when attached to a portable device. Yeah, that's the purpose why we created a new driver unit. And I want to show you the driver right now. I have 3 assemblies and 3 parts of the driver, which I'm going to explain. You have, at first, you see here is the chassis. This is a kind of supporting unit or a frame that holds everything together. And we have the diaphragm, which is put inside the chassis construction, and this positioning of the voice coil, which is attached to the diaphragm, is very crucial. I will come to this later. And on the other side, you have the there is a magnet assembly which contains the strong neodymium magnet, and this is inserted from the back side after the diaphragm has fixed into the chassis construction. So yeah, we are proud to say that the driver was completely engineered in Germany from us, and also for the new driver we set up an own production line here in-house at our facilities in Heilbronn. And having this production line here is a very big benefit, because we can keep track on all the production processes and maintain a very outstanding quality. So every driver unit do sound the same, and this holds also for the headphones, for the produced headphones. So now I want to go through the different parts of the driver itself and explain a little bit the purpose and the function of it. So starting with the diaphragm itself. Yeah, the diaphragm is very important for the driver because it's the interface of the mechanical and the acoustical domain. So mechanical motion is transformed into an acoustic wave, so to say. And yeah, we have for the Stellar 45, we have a diaphragm with a diameter of 45 millimeters. So you may now get why it's called Stellar 45. Yeah, and for the film material of the diaphragm, we are using a compound film that is made of 3 layers. We have 2 cover layers that are encapsulating a damping layer. And this damping layer is needed for acoustical reasons, for the damping. Yeah, these cover layers are made from a specific high-tech polymer material, which is called PEEK. peak has very good mechanical properties, so it has a very high durability and a very high resilience. So it is therefore it is also used for medical applications or aerospace applications. And these peak layers are encapsulating the damping layer film inside, and they are protecting it against environmental influences or external interferences. So we assure that the sound will stay the same over the complete lifetime of the driver unit. And also, due to the isolation protection, the sound is also less dependent on temperature or humidity. And there's another feature of the diaphragm, which I want to show you right now. As you can see here, there's a very unique pattern at the circumference, at the surround of the driver unit. And we need this pattern to control the radiation pattern, and it also intentionally influences the driver's response, sound pressure frequency response. And the other reason for this is to keep the movement of the coil inside the gap only in that direction, so prevent rocking motion and control the movement in such a way that the voice coil always stays inside the gap during operation. So this is very important. And we see here also the voice coil that is attached to the diaphragm itself, and the voice coil is also very special. We use a very high-tech wire for the voice coil, which is made from copper-clad aluminum and with an additional high tension coating. So the reason why we chose a compound wire is that we will save 50% of the weight. So we can make very high voice coils with a coil height of 3.2 millimeters and a weight of the coil of only 80 milligrams, which is very little compared to competitors. And as I already said, the diaphragm is put into the chassis with a very precise process, and we put a lot of effort in the process verification phase and pre-production to get this very accurately and very precise, because the positioning of the voice coil is very crucial. We only have an air gap of 0.6 millimeter, so the voice coil needs to be aligned perfectly in the center of the air gap. So we are happy that we got this process very stable, and so we are able to maintain a very consistent quality, which is very important. Now let's switch to the motor of the Stellar 45, which is part of the chassis construction. And as you can see, for the motor you see a magnet in the center, and the other parts of the motor itself, for the motor assembly, we have a pole place at the bottom of the magnet and a washer at the bottom, and this ring that is already inside the chassis construction. And these materials are made from ferromagnetic steel. The magnet, for the magnet we are using a very strong magnet material, a neodymium magnet with a very high magnet grade, N52. And the magnet induces a magnetic field inside the motor assembly, and the parts of the motor are guiding the field lines of the magnetic flux with little losses because of the ferromagnetic properties. And the flux is concentrated in the center, or in the air gap, and we reach a very high flux density here, which we need for very high sensitivity. And the flux density is about 1.15 Tesla. So how do the Stellar 45 driver generates the sounds? So I will explain it to you in the next schematic slide. We see the voice coil that is positioned inside the air gap, and if you would fed an electrical signal to the voice coil itself, a current will start to flow, and the current flows through the turns of the voice coil itself, and due to the dynamic transducer principle, a Lorentz force is generated, and this force makes the voice coil move up and down, and the voice coil is attached to the diaphragm, and so the diaphragm gets pulled and pushed by the voice coil, and so the diaphragm gets excited by the voice coil. And this leads to different vibration patterns, which I want to show you right now to give you a better understanding of the vibration behavior of such a headphone driver. We see at low frequencies the diaphragm is moving completely in phase. It's like a loudspeaker driver. But this changes when we reach a frequency of about 3K. So we see first breakup modes. So this is the transition. The driver unit is changing from a pistonic motion to a bending wave transducer. And the higher the frequencies, the more complex the structure gets. And we need these bending modes to cover the whole frequency range, because we only have one driver that has to cover everything, the whole frequency range. And due to this feature, we are able to get a very good treble extension of the driver. So if you take all involved areas that are vibrating, you can calculate the driver's frequency response like it would be built into a flat panel, into an infinite baffle, so without the influence of the headphone itself. And as you can see in the next slide, we have a very nice bass extension of the driver unit, very remarkable for a headphone driver. And at around 4 kilohertz, you can see there is a little plateau starting, which goes far beyond the 20K. And this plateau is needed for our sound character and for our good sound. And due to this, the headphone and the driver is able to catch every detail inside the recording. So we need this treble extension here. Finally, I want to talk about the topic of distortion. Normally an acoustic transducer should not add distortion to the original signal, but in reality this is not true, of course. So you can imagine the sound wave that is propagating through your ear channel and is arriving at your eardrum. The signal shall normally correspond to the original one, but due to the nonlinear properties of the driver, it gets altered. So a measure to describe this alteration is a THD, the THD value, which stands for total harmonic distortion, and the THD sets into comparison the higher order harmonics in comparison to the fundamental tone, which is used for exciting the driver. And luckily for the Stellar 45, we only get little distortions even at higher sound pressure levels. And we had one major measure how we achieved this low distortion capabilities. And it's again the long voice coil that I already showed to you, and the combination of the very lightweight coil wire. And this enables us to make long voice coils that are completely reaching through our air gap and are protruding at the bottom side of the air gap, as you can see in the schematic view. And even during operation, the coverage, so the all field lines inside the air gap are catched by the voice coil. So also the driving force is kept constant, and this is very important for the low distortion capabilities of the Stellar 45 driver. And besides that, we also, of course, optimize the mechanical properties, the restoring forces of the diaphragm in order to get the distortions as low as possible. So finally, I want to show you a little bit the distortion performance of the Stellar 45 driver. And to illustrate you the capabilities of the driver, we put had an acoustic coupler which mimics the acoustic properties of an open back headphone, and we measured or conducted measurements of different competitor drivers and also the Stellar 45 driver under the same acoustic conditions. So this was the intention for this acoustic coupler. And as you can see, we have the THD value. You remember, the lower the better. We have a chart here where you can see on the left axis is the THD value, and at the bottom axis is the sound pressure level. And with increasing sound pressure level, you can see that the THD value also rises. But for the competitors, you see rapidly a very steep slope of the curve, while the Stellar 45 driver is kept quite flat, also for high sound pressure levels. So I think this shows really good the performance of the Stellar 45 driver and the capability of deliver very high sound pressure levels with low distortions. So that's it. Thanks for joining our session.
Yeah, and as I said in the beginning, now you can ask your questions in the Q&A session. Thank you, Sebastian, for the fantastic performance and presentation. And in the back, we have actually our colleague, Simon, who will read out your question if you have any. And we will try to answer everything.
Hopefully.
Yeah, hi. Alex wants to know, he has an 880 headphone and he has been pursing his sound baffle, the white fleece on it, and he wants to ask how detrimental it is to the sound, if it's bad or... Maybe, Sebastian, you can give insight on that.
Yeah, that's not so good because we need this, as I explained it already, this fleece is very important for the separation of the front and back chamber. If you destroy the fleece, then you will get an acoustics shortcut and you will kill the low frequencies. So this is not good. What you can try to do is try to cover the hole by a little piece of adhesive tape, for example. This could be a workaround, or you can buy a new headphone, like a DT900, for example.
Or, of course, exchange the part as we can exchange the driver and everything
of course,
as spare part.
Yeah. Hope this answers your question.
Yeah, thank you. Are there further questions?
Okay, so if there are no further questions, I think you can also always reach us via our social media accounts. You can, of course, check out our virtual exhibit at this NAMM show. And if you have any questions, furthermore, or maybe you will find something else to ask later on, then get in touch with us. We're happy to answer everything. And thanks a lot for joining in, for sticking with us, and have a good NAMM show, even in this digital format.
Thank you very much.